this video I'm going to show you how to change a binary value to BCD values. Specifically in this specific video I'm going to show you any value between 0 and 99 binary value, which can then be changed to two different BCD values, and I'm going to display that on two 7-segment displays. So I'm just showing you an example here of what I've done on Proteus. I'm making use of an AVR microcontroller. In this specific instance, I'm making use of port D to basically write the data out. The lower nibble is connected here. So this is going to be a BCD value that's going to be displayed here. This is a BCD to 7-segment display, and the lower nibble of port D will then basically push out the value. In this specific case it's going to be a 6. You'll see how I get there, but it's actually displaying the ones of a binary value. The upper nibble of port D is also connected here to this BCD to 7-segment display decoder, which is then also connected to the binary values second digits, which is the tens. So in my program, and I'm going to get to the program, I've written a program in Atmos Studio, but the whole purpose of this video is just to show you how to convert a binary value to two BCD values. So in my program, what you see in yellow here, you will also see in my program, but this is the way it's done. So I've actually declared two chars here, a high and a low char, and in this specific case in my program I have just made port D of the AVR an output port, and then what I've done here is I have assigned a value of 76 to a register, a variable by the name of display val. Normally this display val would be changing. If you for instance make use of an ADC, the ADC value will change constantly, and which actually means your display will also change constantly. But for now, just to show the principle, I have made this as a fixed value, a fixed constant of 76. But you'll see in the process, if display val changes, you can change your program slightly and it will accommodate that. So in my program I have said here, I've used this line of low is display val, and this symbol here is called modulus. It looks like a percentage symbol. It's modulus 10. So what this means, this specific line, what it means is, let's first of all just have a look at this. Display val is equal to 76, and 76 in a binary format looks like this. So if you want to display this as it is, it's going to give you just a lot of junk. The upper nibble will be showing a 4, and the lower nibble will be showing something which I'm not sure what it's going to be, but it will definitely not be correct. It would need to show 76 and it's going to display something totally different. So with a specific line where it says low is equal to display val modulus 10, modulus 10, what this means, it's actually, it means you divide by 10, you take display val and divide it by 10, but the answer is you need to keep only the remainder. In other words, the value of 6 will be loaded into the variable low. 76 divided by 10 gives you 7, and there's a remainder of 6, and this is what is kept. 6 is kept as the answer is placed in low. So what you will have in the variable by the name of low will actually be the 4 zeros, 0, 1, 1, 0, which is 6. And so at this stage already I started off by saying display val is 76. So now I've actually collected already this green area, the lower nibble here, shows that is the 6, and that is the 6 that I want to display at some point. In my program, the next line is this one here, where it says high is equal to display val divided by 10. Now the difference, of course, between modulus is storing or capturing the remainder, whereas divide by is actually losing the remainder and just keeping the whole value. So I is equal to display val divided by 10 means it's 76 divided by 10, which means in this specific case the 7 will be kept and the 6 will be removed or be discarded. So in high, in the variable by the name of high, you will sit all of a sudden with 4 zeros, 0, 1, 1, 1, which is 7. So now we can see I've already, from display val, I have captured a 6, and I've also captured the 7. I must just basically arrange them now to display them correctly on the 7-segment displays. And this is why I've used this last line here. So in this last line, as you can see, what I've done here is I've said move the high variable, but the variable by the name of high, move it 4 positions to the left, or shift it 4 positions. So what's happening here is basically that this value that you see there is being moved 4 positions to the left, meaning that this 7 will now sit in the upper nibble of high. So this is what's happened here. So as you can see, in high, I'm now sitting with 7 as an upper nibble, and I'm sitting with 6, which is this one here, which you can find in the variable by the name of low. And if I OR them here, I'm basically ORing the two together. So if you start ORing them, that upper nibble will be, the output will be exactly the same. And the lower nibble of low will also be placed here. So what do we have here? We've got a value of 7 and 6. And this is exactly what I want to push onto port D. So once I push this out on port D, it will display 76. So let's have a look at my program. Like I say, the purpose is not really to explain the whole program, but what I've done there, this is exactly in the program. I'm just going to build this, and then I'm just going to make use of this Proteus. I'm just going to stop this one here, and I've already preloaded this thing, and if I tell this thing to run again, it will show 76. So if I go to my program, and as I've said, I can have any value between 0 and 99. Let me just change the display val to something like, let's say 18 for now, and let's just build this. And if I get to my Proteus design, if I stop again and I just start, you will see that it's displaying 18. And the last one, maybe a value of, let's put in a value of 96 for instance, and again build this. And if I look at my Proteus design and stop this and start this, it will display 96. So, and as I've said, in your program, if you write a program where display val is continuously changing, now I've done it manually by changing the value, but in a real program, display val can change continuously, and by just using this short program here, you can actually display any value from 00 up to 99. Thank you.